Okay guys, so here's K-11. So we're gonna do basically like the same stuff but with more calculators. So we're gonna have to store the intersection points of the graphs. Okay, so same formulas as before. Find the area bounded by the curves f of x equals this and g of x equals that. You may use Math 9. Okay, so whenever you're asked to find the area between two curves but you don't have the graph, you've got to graph it. Okay, so you go to your graphing calculator, 4x squared minus 10, and then negative 3x minus 8. Oh, whoopsie, I did them in y2 and y3. I guess it doesn't matter, but negative 3x minus 8. Okay, and then you graph it. I don't have the best window. Okay, so if you hit a situation like this where your window is not great, first I would go to zoom standard. All right, that'll give you a 10 by 10, not 10 by 10, it's 20 by 20. X min negative 10, X max positive 10, Y min negative 10, Y max positive 10. You could see that on the window. X min, X max, Y min, Y max. Okay, and then we want the scale to be 1 because then that just means these little hatch marks signify 1 unit. Okay, so guys, it looks like what I'm looking for, the region is a little bit lower. All right, so you look for the intersection points. It looks like there's 2 of them here, which makes sense because it's a parabola and a line. So I want to zero in closer to this right here. So the first thing I'm going to do is I'm going to move my Y min, that's my lowest Y, I'm just going to move it down a little bit. So Y min is here. Instead of negative 10, I'll do negative 15. Okay. And then I'm going to use zoom box to get like an even tighter view of this. So zoom box. Okay, so I scroll to the left. All right, so I'm making a box. This is going to be the upper left corner, and then down here will be the bottom right corner. You only hit enter after these 2 corners. Okay, so I hit enter. Then I go to the right. Then I go down here. So you hit enter when you start the box, you hit enter when you end the box, and nowhere in between. Okay, that gives you a nicer view. All right, so we're gonna, so I'm gonna draw this. All right, and it's actually not even super necessary, I guess, to draw the X and Y axis. If they distract you, you don't have to. But it looks like, the parabola is, something like this. And then we've got, the line coming through like that. Okay, these are the intersection points. So when you're looking for the area bounded by the curves, you look for the intersection points. They're going to be part of what encloses the region. So think of these intersection points as like the corners of the closed region. Then you will see what it is. It's that region right there, okay, that we're looking for. So we're going to find the area. So top minus bottom or right minus left. You could see pretty clearly that top minus bottom. Right? If top minus bottom works, you definitely want to use it. Okay, so I guess I'll label this. So this is f of x equals 4x squared minus 10. And then this one is g of x equals negative 3x minus 8. Okay, so I know it's top minus bottom. I want everything in terms of x. Everything already is, so that's good. So I'm going, so it's going to be the integral top minus bottom dx. Okay, now for these limits of integration, okay, so that's the leftmost x value, that's the rightmost x value that encloses the region. You need to find these intersection points, all right? And we're going to see in a moment that they're not going to be rational. So we're going to need to store them. Okay, so this point up here, let's find. So second calc, intersect. You scroll over to this, and guys, these calculator things have to be very fast. okay? So if you're not fast at it, just try the same problem even over and over and over until it becomes fast. Okay, so the intersection point is like, you know, there. Now, for my graph, I'll just estimate. So this is like negative 1.175, comma, negative 4.474. Okay, but we can't use these estimates, okay, when we're doing the integral. Okay, just for like, you know, to maybe help visualize better. All right, now I'm gonna, but before that, I need to store this. Okay, I need to store this x coordinate as a. All right, so I'm gonna write, or actually let me go, okay, so second quit, hit X, because it'll remember. I'm gonna write this down, negative 1.17539.053. And then I am storing it as A. So I hit store, I hit A, and there it goes. Okay, it's saved in my calculator. Now let me do the other intersection point. All right, I want to go here, intersection. Okay, so this one is about 0.425, comma, negative 9.276. All right, and you can even use less than 3 decimal places. I'm just putting these on here just to help us, I don't know, have a little more information. Okay, and then I go second quit, X. All right, so this X coordinate here, I want to save as B. All right, so I'm writing it down. That's 0.4253905.297, and I will store that as B. Okay, so store B. Okay, and now I'm going to do the integral. So it's going to be the integral from the leftmost x is I have stored as A. You can call it A here as long as you've told your reader like what it is approximately. And then the rightmost x value is B. And then top minus bottom, the top, yes, so you go like this for top minus bottom. Top, bottom. So the top function is the line, the bottom function is the parabola. So I do negative 3x minus 8 minus, you need parentheses if what you're subtracting has more than one term. All right, and then in my calculator, I'm going to go math 9, A to B, and then I'm just going to plug this in. You could distribute the negative if you want. Negative 3x minus 8 minus 4x squared minus 10. Okay, so this is equal to 2.735. Okay, it is important, guys, that we round to at least 3 decimal places on the AP exam. Okay, so there's one. Let's do another one where we're given the picture. So find the area bounded by the functions f and g. You may use math 9. Okay, let me focus this a little better. Is that even better? That's a little better. Okay, so I look at these graphs. I've got actually 3 intersection points. So if you got 3 intersection points, there's probably two bounded regions, you know, one for each like pair of consecutive intersection points. So between these, we've got this region. Between those, we've got this region. So we're going to need 2 integrals because we've got 2 regions. Now, guys, we can verify this, but I'm just going to save us some time. That's 0, 0 right there. Now, I'm going to need, yeah, did I already show you this? Yeah. They both regions pass the vertical line test. They do not pass the horizontal line test. Look at that. Okay, neither does that one there. So, yeah, so I'm going like this for both. So top, bottom, top, bottom. So in this region, the pink one is the top. And in in this region, the blue one is the top. Okay, so I'm gonna have, all right, so it's gonna be, I'm gonna have, you know, top minus bottom d in terms of x plus top minus bottom, all right? And then I need, okay, and then I need these endpoints. Okay, so we're gonna find these intersection points here. So I'm gonna graph this. I should have already typed it in to save time. But, so x squared, and then x to the third minus 3x. Let me just go to zoom standard for a standard window. Okay, yeah, so you can see that. I'm going to do zoom box. You don't have to, you know, especially if you can see it fine. If you can see things fine. So I'm going to start the box up there. So I hit enter, and then I go like this. Right, zoom box. Okay, there it is. And now I got to find these intersection points. So second calc, intersect. I go close to here. And then this is, all right, let me first do like a little estimate. Negative 1.303, 1.697. All right. Oh, I got to save it first. So second quit x store. All right, I'll store it as A. All right, so this one here is stored as A. Let me say maybe like over here, negative 1.302. Yeah. And guys, you don't even have to, like, I'm writing out the whole decimal. I don't know why, it just feels better to me, but you don't have to. All right, so that's stored as A. When you're showing what's stored, you know, you're fine to just write a few decimal places. Okay, now I got to do the other one. So second calc, intersect, we're almost done. And then I go over here. Okay, and then let me do a little estimate, and then I'll store the real thing. 2.303, 5.303. Okay, and then I hit quit x, store as B. Okay, so now this is B, 2.302775638, stored as B. Okay, I just got that right for my calculator. Okay, now we can do the integral. So the integral from the x value A up to 0, top minus bottom, this time top is the cubic. The top one is the cubic and the bottom one is that. So it's going to be x to the third minus 3x minus x squared dx plus. Now we're picking back up at 0 and then going all the way to the x value B, which is stored, and then it just switches. So that the quadratic is the top. We need parentheses around the cubic. If you're subtracting more than one term, you need parentheses. And now calculator. Math 9, A to 0, x cubed minus 3x minus x squared plus 0 to B, x squared minus x to the third minus 3x. Did I get the same thing as last time? I hope so. Oh no. Last time I got 1 point. Last time I got 1.378. Geez, I think I'm right here though. Squared minus, okay, so what is A again? A is the right thing. What is B again? B is the right thing. Guys, I'm sure that this has to be right. Okay, if I made a little mistake, you know, let me know about it. And then I could type something by the video, but yeah. Okay, 6.083. Okay.